Okay, you guys, so right now we're going to cover 7.1. This is probably going to be 7.1 and 7.2 because they're basically the same section. It's just 7.2 is like kind of the harder versions of 7.1. So the first thing we want to do is find the inverse sine function. So what we're going to do first is look at the basic sine x function, okay? So we're going to deal with that. We're just going to say, okay, we have y equals sine of x, and this is what we would get, okay? Now, if we want to find sine inverse, right, we're going to say y equals sine inverse of x. By the way, it also has an equivalent way to write it. They also say y equals arc sine of x. Okay, that is these two things mean the same thing. There is no difference. Okay. Now, hopefully you guys remember from pre-calc. I'm sorry, not from pre-calc. I have to review this with my calculus students all the time. Sorry about that. So hopefully you guys remember from the previous sections, we talked about, I believe it was in 5.2, or no, maybe, yeah, it was 5.2 where we talked about one-to-one functions and their inverses are also functions. So as you can see, very obviously, the sine function is not one-to-one. It fails the horizontal line test, so it is not a one-to-one function. It does pass the vertical line test, right? But it does not pass the horizontal line test. So it is a function, but it is not a one-to-one function. So what mathematicians decided is we want to be able to work with the inverse of the sine function. So basically the sine function spits out a ratio of side lengths of y over the radius that would be generated on a right triangle. So it's a ratio, okay? So it's saying what angle, it says the sine of this angle would produce this ratio. So what the arc sine is going to do is it's going to go backwards. The arc sine is going to say, well, what if you were given this ratio? What angle would it have created, okay? And because of that, there's limitations that are put on it. So first thing we notice is that if we want to make this a one-to-one function, what we're going to do is we're going to erase the part of it that we don't like. And it's not that we don't like, but that we don't need to be, or that we can't use in order to talk about one-to-one. Now let's look. It's still a function, and does it now pass the horizontal line test? It now passes the horizontal line test, so this is now a function. But what I've done is I've limited the domain. The domain is now from negative pi halves to pi halves, right? Those are the angles we're allowed to use now. And the range is still the same. The range is still -1 to 1. So what we did is we cut off part of the graph so that we're able to call it a one-to-one function. That way that its inverse will also be a function, okay? But we know then that a inverse function now will take on, so if we're going to do sine inverse, the domain will be the range and the range will be the domain, right? So that means now we're going to have -1 to 1 as what we're allowed to plug in. And what we're allowed to get out as our answers are from -pi/2 to pi/2. So remember, the domains and ranges flip-flop, okay? That's a big thing about inverse functions, okay? And we also need it to be a reflection across the line y equals x. So remember, I was supposed to be able to draw this line right through here. Oops, you guys kind of get it. And then I was supposed to be able to draw a reflection across that, okay? So what we're going to do is we're going to have our domain limited from -1 to 1. And then we're going to have our range limited from pi halves to -pi halves, okay? So that now means that our graph is going to go something like this. Oops. Let me see if that's kind of going to be a reflection of it. Let me graph it on my calculator and I have a hard time visualizing it in my head. Let's go to mode, let's go to function. Okay, so let's graph sine inverse of x. Yeah, it's kind of like that. I'm just having a hard time visualizing it. So it's going to go a little bit like this now. with just a little bit of curve to it, okay? So now that is the reflection, supposedly, and again, my drawing isn't perfect, but that is now the reflection of that, okay? So what the arc sine, one of the main things that I see students, you have to remember this. So if we're going to draw the unit circle, one of the main things I see students kind of forget is pretend you have the unit circle like this. So when you're dealing with arc sine, you can only go from negative pi halves to pi halves on the unit circle. This is all you can work with if you're dealing with arc sine, okay? If you're dealing with arc cosine, it's different, and we'll talk about that for arc cosine, okay? Hold on one second, let me turn on the light. So what we're going to write now is we're going to rewrite this. We're going to say that we read, so we read y equals sine inverse of x as, so this is how you can think of it. Y is the angle or real number whose sine would equal x, okay? So let me just kind of tell you, and again, sometimes you don't have to think of it as inverse sine, sometimes we just know the answer to it. So if I gave you sine inverse, sine inverse of 1, okay? So what I'm really saying is I'm saying that that is the angle. So what I'm going to do is I'm going to set this equal to theta. You could also call it y, okay? So I'm saying that the sine inverse of 1 is an angle, okay? So that's the big thing you got to understand, is that the inverse sine is actually an angle, okay? So what I'm going to do then is I am going to say that sine of what angle would give me 1. So this right here is the ratio, and this is the angle. So I want to know what angle, when I take the sine of it, would give me 1, okay? So that's how you can reinterpret it. And I'm going to show you more stuff to it. There's a little bit more to it than that, but this is a good way to think about it, okay? So then if you think about it, sine of what angle would give you 1? So if we go up here to the unit circle, well, wouldn't that be right here? Right there at pi halves, it's worth 1. So we say theta equals 1. So this is what it's actually saying, but this is what you're actually trying to find, okay? You're actually trying to find what angle would create this ratio of 1, okay? Let's look at another one, okay? What if I said sine inverse of negative 1/2, okay? So what I'm going to do is I'm going to say, well, this is some angle, right, theta. So I want to know the sine of what angle theta would give me negative 1/2. So I'm going to draw my unit circle again, okay? Now I got to think, when is sine negative? Well, sine is negative in 2 quadrants. Sine is negative here in quadrant 3, and it's also negative in quadrant 4, okay? So when does sine have an angle of 1/2? Well, sine has an angle, a ratio of 1/2 at 30 degrees, or pi 6. Remember, this is square root 3 over 2 comma 1/2, right? So that means here, if I drew this here, this would be square root 3 over 2, and this would be negative 1/2. And if I drew it here, this would be square root 3 over 2 comma negative 1/2. So technically I would say, oh, theta is equal, now that would be what, 7 pi over 6, and the other one is 11 pi over 6, I believe. Yeah, but both of those are not right, because remember, we said that the only answers you can get for an arc sine, the only angles that can be spit out, are between negative pi halves and pi halves. So we got to find an angle that's in here that's equivalent to this angle right here, that's equivalent to 11 pi 6. So this one won't work. It's not even in the right spot. It's in quadrant 3 when we're only allowed to be in quadrant 1 and 4. And then this one won't work because it's not between negative pi halves and pi halves. So we have to come up with another angle that would create that same ratio of sides, that same relationship. So then we say, well, theta has to equal negative pi over 6. Okay, so that's how we can deal with it. And there's not another angle. The other angle would be in this quadrant, but we aren't allowed to count that. Okay, so this is what you have to do for these arc sine, arc cosine, arc tangent, is you always have to think about what answers you're allowed to get. All right. And you can also use your calculator to do this as well. Your calculator has you just do second function sine and it'll give you the arc sine function. Sometimes you use that to approximate when it's not like one of the nice 30-60 or 45-45-90 triangles. Sometimes you have to use it on the ones that just need approximations, okay? So let's do this one. Let's find the sine inverse of the sine of pi over 8, okay? And here's a couple facts. F inverse of f of x, so if you have the inverse on the outside function, so this would then be sine inverse of sine of x, which equals x, and f of f inverse of x equals sine of sine inverse of x equals x. And this is where negative pi halves is less than or equal to y, or sometimes called theta, is less than pi halves. And this is negative 1 is less than or equal to x is less than or equal to 1. Okay, so when we go to look at this problem, basically what you're allowed to do is if you take the sine of the sine inverse or the sine inverse of the sine, you're basically allowed to, say that because they're inverses of each other, you're just going to be left with the angle or left with the ratio, whichever scenario you're working with. Notice in this one, this is an angle, and then you take the sine of that angle. And in this one, this is a ratio, right? Sine of x is going to spit out a ratio, and then you're going to take the angle that created that ratio. Okay, so it just depends on what you are working with in that problem. So this one is sine inverse of sine pi over 8. So we have to make sure that y is in between negative pi halves and pi halves. So when we do this, we're going to say that this cancels that, and we're left with pi over 8. Now, is pi over 8 an acceptable answer in this problem? Is it in our interval? Remember we said from here to here, from negative pi halves to pi halves. That's acceptable, right? That's in that restriction. So then what we're going to do is we're going to look at this next one, and I'm going to say find sine inverse of sine of 5 pi 8ths. So again, what this is saying is you first have to find the sine of 5 pi 8ths, and then you find the angle that created that. So let's see what happens, okay? The problem is that if we just try to cancel these again by undoing the inverse and the sine undo each other, and we just are left with 5 pi 8ths, we have a problem because 5 pi 8ths is not here. 5 pi 8ths is a little over 4 pi 8ths, and that would be over pi halves. So 5 pi 8ths is like right here somewhere, right? And that's outside of our restriction. However, the sine of that, okay, the sine of that would have a matching value right here, right? Wouldn't it have a matching value right there? So what you have to do is you think, well, how far away is this? Well, if this is 5 pi over 8, that means this distance is a pi over 8, right? And that means that if I took pi halves plus pi over 8, I got 5 pi over 8. So I should be able to do the same thing, but subtract. So to find this guy right here, I would just do pi halves minus a pi 8ths, and that should give me 3 pi 8ths, right? 4 pi 8ths minus 1 pi 8. Yeah, so we get 3 pi 8ths. So this answer is not allowed, but it leads me to this answer, 3 pi over 8. So this is the correct answer for this problem, okay? hopefully you guys see what I did there. It's kind of hard to explain. Once again, if I was in the classroom, it probably would help a little bit better. You could ask me more questions about it, but definitely come to the meeting and ask about this. You'll see this happen sometimes in the homework where the answer should just be, the answer should just be 3 pi eighths, right? Or I'm sorry, 5 pi eighths, because the sine inverse cancels the sine and it says that we get x here or here. But the problem is it says that your answer has to be in between negative pi halves and pi halves. So you have to find an equivalent version of that to get you there, okay? Now let's do the cosine and cosine function. So it's going to be built the same way. So we're going to think about how the original cosine function is. So we know the original's there, there, and there, right? Okay, and this is what, pi halves, this is pi, this is 3 pi over 2, and this is 2 pi. Okay, now once again, it fails the horizontal line test. So what we do is we erase that, and this is for y, oops, I did sine again. I mean cosine. Please fix this, and you notice that would really butcher everything. Cosine, okay? So this is y equals cosine of x, and we're going to use this to find y equals cosine inverse of x, okay? So what we're going to do is we're going to erase this graph from here, and we're only going to be concerned with this part of the graph, okay? So it's that part, okay? So that means that we now have our inverse, okay, is only going to go, so the domain, and you could graph it on your calculator. It would basically be very similar to the previous one. What we're really concerned with is the domain and range, okay? So the domain of this guy is from 0 to pi, and the range is from -1 to 1. Okay. Now, I have seen in other books, and especially in books in different countries, I think they use a different value for their domain, because you guys understand, I could have also used a different part of the cosine function. I could have used this part over here, right? And I could have said from negative pi, from negative pi to 0. I could have just as easily done that. So this is something that's just kind of agreed upon. But in different areas, they might not have agreed and wanted to do it a different way. And it's still, everybody's still doing the same thing, but this is kind of the accepted, if you're talking about arc cosine, this is the accepted domain. So the accepted domain would then be -1 to 1, but the big deal is the accepted range. What are you allowed to get as your angles? From 0 to pi, okay? So that means if I draw my unit circle, now I'm looking over here. Now I'm going from here to here, right? Now I'm going from 0 to pi. So all my answers have to be in there for my angles that I end up coming out with. So let's look at that one. So let's see here. So what if I asked you find cosine inverse of, oops, not of theta, of 0. So then you guys would say, well, let me set this equal to theta real quick so it makes sense. I'm finding an angle. So what it's really saying is the cosine of what angle would give me 0. Oh, well, you guys know that. Cosine of what angle gives me 0 would be pi halves, right? But wouldn't it also be 3 pi halves, right? So it's down here or here. My cosine is 0 on both those locations, but I can't use that one because it's not in my range. It's not an answer that I'm allowed to get. My range is only from 0 to pi. Okay, so I'm going to use pi halves. Let's look at another one. Let's find the cosine inverse of -√2 over 2. And we're going to say, oh, this equals theta, right? So then if we do this, we then say, well, the cosine of what angle would give me -√2 over 2? Remember, that's what the arc cosine is saying. What angle would give you this ratio right here? Well, we know that cosine is negative in quadrant 3 at, this would be 45 degrees in quadrant 2. So that would be what, 135. And then this would be what, 215, or 3 pi fourths and 5 pi fourths, okay? So we can't count this guy because he's in the wrong quadrant. We're only allowed to use this guy. So we're gonna say theta is this one, And that is going to be when cosine is negative root 2. So that would be 135 degrees or 3 pi over 4. Normally we like to work in radians just so we get more practice with it. But once again, that's how you deal with these inverses, okay? Now the inverse tangent, I'm just gonna do quickly again, and it's all kind of behaves the same. But here's the kind of good thing about inverse tan. It's ready to go. Inverse tangent's already ready to go. So if you guys remember your inverse tangent, there was an asymptote here at negative pi over 2 and here at pi over 2. We had an asymptote there and we had an asymptote there. And then we drew our graph and it went something like this. I draw it a little bit too much like a cubic, but that's basically what it does, right? So that is our tangent function, okay? So this is y equals tan x, right? So if I want to find y equals tan inverse of x, and I need to worry about my domain restrictions, okay? So if we do tan inverse of x, now we start having a little bit of problems. So what you should always do is think about the domain first of regular tangent in just this. Now remember, tangent also does this, right? There's another one and it goes on forever. So what they ask you to do is to just focus on this one interval right here from negative pi halves to pi halves. So our domain is going to be parentheses negative pi halves to pi halves. So this is the agreed upon interval that we talk about the tangent function if we're going to talk about the inverse tangent. And then the range will be from negative infinity to positive infinity. Well, that means when we come over here, we have negative infinity, positive infinity for our domain, and our range will now be negative pi over 2 comma pi over 2. So this one looks a little bit, I'll draw this one because this one looks quite a bit different than the arc cosine. So if we go in here, I'm going to do second inverse tan on my calculator just to give myself a better idea. I always have trouble drawing. So I'm going to put my domain, my range as negative pi over 2, positive pi over 2, right? Let's do it up here. And then my domain is negative infinity, positive infinity. So what this looks like is it looks like this. So imagine this graph right here, but kind of like turned, right? So that's what it kind of does, okay? And again, I might have drawn it too curved, but you guys should get the general idea. This comes up a lot in calculus. People have trouble remembering the domains and the ranges for arc tan. They're not really sure what it means. So like I said, when you get into calculus with me, if you take me for calculus, we can figure that out together. But this does come into calculus with limits quite often. People just have a really hard time remembering arc tan. So I'll just give you one or two of these. So what if we wanted to find, I'll just give you one. Tan, oh, by the way, so our circle, if we're thinking unit circle wise, right, we're here again, we're negative pi over 2 to pi over 2. So it's very similar. It's very similar to arc sine. So what if I say, find the tan inverse of square root 3. So once again, I'm going to set that equal to theta. And then I'm going to say that the tan of theta equals square root 3. So we have to think what angles, when you divide them, will have a square root of 3. So I know that's got to be a 30 or a 60, right? Because a 30-degree angle and a 60-degree angle have sines and cosines that got a square root of 3 and a 1/2 floating around, okay? So it is positive, right? So what angle would give me a positive? Well, that means that if it's positive, that means that the sine and the cosine must both be positive. So I know I'm in this quadrant somewhere, okay? It's either 30 or it's 60, okay? So what I'm gonna do is I'm gonna say, well, what if it was 60? Or pi thirds, right? So if it were 60 degrees or pi thirds, that means that this would be 1/2. Oh, wait, no, that's square root 3 over 2. Sorry about that. And this would be 1/2, right? So now what I'm going to do is I'm going to say, well, what angle would give me square root 3? So what I'm going to do is I'm going to double check, and I'm going to find the sine of theta divided by the cosine of theta. Well, if this is my theta, right? If it is in fact 60, Well, then that means that I should get the square root of 3 over 2 divided by 1/2. Well, that would be square root 3 over 2 times 2 over 1, cancel, cancel, and we're left with square root of 3, okay? And that's what we got. So that means that it is in fact 60 degrees. So this was all just kind of like scratch work, you guys. If you can see it without doing that, that's okay. So then we would just say, well, theta had to be pi thirds or 60 degrees, right? It could also be over here, but that's in quadrant 3. In quadrant 3, it's also positive, but the problem is that's not in my ranges. I'm not allowed to get that as an answer. Okay, so this would be the answer, depending if they ask for radians or degrees. So that's basically 7.1. Let's see if I have anything else in there. Let me just double check, make sure I covered everything I wanted to. Yeah, I think that'll be it for that one. So what I want to do now is I want to move on to 7.2, but I'm not going to make it a new video because 7.2 is basically now just saying, now that you know how to do inverse trig, let's do some exact values. So let's 7.2 inverse trig continued. Okay. And we might also work with secant inverse, cosecant inverse, and cotangent inverse. They also have restrictions as well. Yeah. Let me see here. So I want to find the exact values of, and then I'll give you sine of the tan inverse of 1/2. Okay, so here's how you set this up. Remember, this is theta, right? So I'm going to say that tan inverse of 1/2 is equal to theta. Okay, so I'm going to say that. I'm going to say tan inverse of 1/2 is equal to theta. So this is really saying sine of theta, right? So we just have to set up theta. So what we're going to do is we're going to build our triangle. Now, because we're working with tan inverse, we're saying tangent of some angle is going to give you 1/2. So when is tangent positive? It's positive in quadrant 1 and in quadrant 3. So we're either in quadrant 1 or 3, but we know that tangent is restricted to quadrant 4 and 1. So we know that we're here. We know that we're somewhere here, right? We're not exactly sure where. So I'm going to draw my little triangle. I'm going to draw my triangle, okay? But we know this is theta. And again, I don't know what theta is, but I know that's theta. And I know that tangent, okay? So there was something that you guys might have learned in a different class. I didn't talk about it because normally everybody knows it, but SOHCAHTOA. This helped me a lot. So what this means is sine is the opposite side over the hypotenuse, okay? Or in this case, you know, we learned it would be the y value, okay? And then the cosine is the adjacent side over the hypotenuse, okay? And then tangent is the opposite side over the adjacent side, okay? So this comes in handy for me here because I really like to, I don't even like to worry about what side is y and what side is x. I just want to know what side is the opposite, what side is the hypotenuse, and what side is the adjacent side. So if this is theta, right, this is my angle theta, that means that the opposite side is 1, right, because this is opposite, because we're doing with TOA, tangent. This is the opposite side over the adjacent side, which would be adjacent like that. So that means the opposite side is 1 and the adjacent side is 2. But if you know two sides of a right triangle, you can always find the third. So we're just going to do 2 squared plus 1 squared equals c squared. So this becomes what, 5 is equal to c squared. So square root of 5 is equal to c. So we now know this side is square root of 5. So now you can ask me anything you want about theta because I have all three sides. So they want to know what is the sine of theta, right? Because remember, I said that's what they're really saying is what's the sine of theta? We said that theta was worth the arctan. So now we're just going to say, well, the sine of theta is worth, well, what does sine stand for? According to this, sine stands for opposite over hypotenuse. So what's the opposite side? 1. What's the hypotenuse? Square root 5. So we're going to say 1 over the square root of 5, but you guys aren't allowed to leave that with an irrational denominator. So you say square root of 5 over 5. Okay, and that would be your answer. That's how you do it. Okay, let's do another one. So this is kind of the flavor of 7.2. It's just now they're saying, instead of doing tan of tan inverse or sine of sine inverse or cosine of cosine inverse or vice versa, they're going to switch it up and make you build your own triangle. Okay, so now we're going to do cosine of sine inverse of -1/3. Okay, and remember, this is really just saying cosine of theta, because sine inverse of -1/3 is equal to theta. But what that's really saying is the sine of theta is worth -1/3. Remember, that's what arc sine is saying, is this is the ratio that's created, and what angle would have made that happen. Okay, so we're going to draw our triangle. Now, what quadrant are we in? Let's draw our unit circle. And I hope you guys are seeing that I'm always drawing the unit circle, like I'm always referring back to it. So the arc sine function only exists in quadrant 1 and 4, from -pi/2 to pi/2, right? So in which of these quadrants is sine negative, right? So that's what you have to think. So that means we're over here somewhere. So I'm going to take my triangle, and I know this looks something like this. And this is now my theta, and that's my right angle, okay? That's my theta right there, okay? So now sine stands for opposite side over hypotenuse. So my opposite side is -1, and my hypotenuse is 3. And again, I know that the side length can't actually be negative, but it's just to remind me that I'm going downward, okay? So now we can figure this out. We can do b squared plus -1 squared. It's not even -1, it's 1 squared. I know what you guys are saying, but 1 squared. And then that would be worth 9, right? Because 3 squared. So then we have b squared is equal to 9 minus 1 would be 8. So then b is equal to 2 square roots of 2, right? Or the square root of 8. But you must always simplify in this class. So this will be 2 square roots of 2. All right. Hopefully you guys have that. So that means that this is 2 square roots of 2 now. So now I have everything, right? I don't even know what the angle is, but I can answer any trig question about theta now. So I'm going to come over here, and I'm going to say the cosine of theta is worth adjacent over hypotenuse. Well, what's the adjacent side to theta? It's this side right here, because this side is the opposite, so this must be the adjacent, and this is the hypotenuse, okay? So that means adjacent, which would be 2 square roots of 2 divided by the hypotenuse, which is 3. And there you go, that's it. So it's a lot more work than 7.1. These problems actually require a lot more thinking and kind of drawing pictures of where you're at. So it's really important that you do that. So the next one, cosecant of the arc tan of theta, I'm sorry, of -2. Now again, we know that they're saying, this is really the same thing as saying cosecant of what angle? I'm sorry, cosecant of theta, right? They want to know the cosecant of theta. So what we're going to do is we're going to come down here, and we're going to take tan inverse and set it equal to theta, okay? Because that's what it is. That's what an arc tan is. Is it some angle, we don't know yet, that created -2 as its ratios built in the triangle. So let's see here. I lost my train of thought. Oh, so then we're saying tan of what angle, theta, would equal -2. Okay. Well, let's draw a triangle. What quadrant are we in? What quadrants are tangent negative? We draw the unit circle. Well, quadrant 1, tangent only exists from here to here, right? It only exists for arctangent. So we only can go from negative pi over 2 to pi over 2 for arctan. And in these quadrants, when is the tangent negative? Well, it's down here, right? It's in this quadrant. So I should have been using green. Sorry about that, guys. So we're going to take this triangle. We're going to call this theta. And again, we don't know what it is, but we do know that tangent is SOHCAHTOA, opposite over adjacent. So opposite side over adjacent side. So the opposite side is -2. The adjacent side is 1. So that means we can do 1 squared plus 2 squared equals c squared. So this would be what, 4 plus 1 is 5 equals c squared. So square root, square root. So once again, we get c is equal to square root of 5. That's just a coincidence, okay? So that means I'm going to put a square root of 5 right here. So now when they want to know cosecant of theta, well, what would, remember, cosecant is really 1 over the sine of theta, okay? So in this case, what I'd prefer to do is I'd prefer to just find sine of theta and then turn it upside down and use the reciprocal. So the sine of theta is equal to what? Opposite over hypotenuse. So then that means that the opposite side is -2 over the hypotenuse is square root of 5. So then cosecant of theta is the reciprocal of that, which would be square root of 5 negative over 2. Okay? So that's how you can use the properties in chapter 7.2. Or I shouldn't say the properties, but it's just now continuing on and giving you harder problems. Okay, let's try another one. Just so we kind of, let's do cosecant, okay? So cosecant inverse of 2, okay? So a few things I want to talk about first is that for cosecant is negative, is between theta and pi over 2. So remember that cosecant is really saying cosecant of theta, remember this is equal to theta, so cosecant of theta is equal to 2, okay? But remember cosecant is really 1 over sine theta equals 2. So what if I flip both sides? I'm really saying that sine of theta is equal to 1 over 2, okay? So in general, your cosecant function has similar domains and range issues when you're doing the arc as its associated one. So we know that theta, or sometimes y, has to be between negative pi halves and pi halves. So when we're doing our unit circle, we know once again it has to be between here and here. Okay. We also know that theta cannot equal 0, or y cannot equal 0 for cosecant inverse of x equals y, or cosecant inverse of x equals theta, whichever way you want to go with it. It's basically representing the same thing. Okay, so this cosecant, because it's associated with sine, it has the similar range issues. It has a similar restrictions put on it. Okay, so that means when would the sine be a positive 1/2? Okay, when would sine be a positive 1/2? Well, sine would be a positive 1/2 right here at 30 degrees, or pi over 6. So I'm going to say theta is equal to pi over 6. So I want you to kind of keep in mind, what I ended up doing is, instead of actually doing cosecant, I just did sine and flipped the value. So it used to be a 2, I used the reciprocal to get 1/2. So whatever angle would have made a cosecant of theta equal to 2, well then its sine of theta would be 1/2. And all I care about is finding what angle would have created this ratio. So I found the angle that would have created a ratio of 2 for cosecant, but that same angle would have created a ratio of 1/2 for sine. So the answer is theta equals pi over 6, okay? Let's do one more. So let's do one that you have to use your calculator for. So we could say secant inverse of 4. Now we have to go to the secant, and remember that cosine is associated with secant, and cosine was where it had its values for y or theta, whichever you want to use, is between 0 and pi. Y cannot equal pi over 2, or theta cannot equal pi over 2, for secant inverse of x equals y, okay? So, and I hope that makes sense, because secant is 1 over cosine, and cosine at pi halves is 0, so you'd have 1 over 0, which is undefined. So that's why they're being a little particular about this one, and a little particular about this one as well, okay? So when we do this, once again, we're going to say that theta equals secant inverse of 4. I name it an angle, and then that means that the secant of theta would be 4, right? That's what that's trying to tell you, right? So the secant of theta is 4, but I didn't ask, I'm sorry, but it's sometimes a little bit annoying to try to find secant. So what I do is I find 1 over cosine of theta is equal to 4. So then I flip both of them, and then this becomes cosine of theta equals 1/4. Okay? So what I'm looking for is the cosine of what angle would give me 1/4. Well, that's not one of the ones we have memorized, okay? So then what we have to do is we're going to refer back to our other stuff, as we're going to take the cosine inverse of both sides, okay? And remember, what that did was that canceled this and this. I guess I kind of danced in a circle. I could have just gone from here, but I wanted you guys to use cosine so it's easier on your calculator. So, and I think actually it might not be as doable on your calculator without doing this. So this becomes theta equals cosine inverse of 1/4. Now, because this isn't one of the ones on the unit circle, we're going to approximate to 2 decimal places. So I'm going to do second function cosine inverse of 1 divided by 4 on my calculator, and I get theta is approximately, and I'm in radians, 1.32 radians, okay, not degrees. This is 1.32 radians. So probably like, well, 57 degrees is 1 radian, and this is 1.32. So we're looking at probably like, I don't know, 70, 80 degrees, somewhere in that range, okay? So sometimes if it's not something on the unit circle, you have to use your calculator, and you have to find the arc cosine of some number on your calculator, okay? So that's kind of how we do these problems that kind of get extended past that. There's also arc cotangent. I don't have one for arc cotangent, but it does everything the same as similar to cotangent. Actually, no, arc cotangent is the only one that it doesn't really fit the mold. So y equals cotan inverse of x. That has a range. What your answers are allowed to be is between 0, y, and pi, okay? So hopefully you don't run into all of these. I can't obviously put all of these on the exam, but I would say the 7.2 homework questions are really good test questions. 7.1 almost seems a little too easy. So probably when you're doing your homework, really make sure that you know how to do 7.1 and 7.2. Actually, yeah, let me rename this real quick for you guys so it doesn't throw you off. So this is 7.1 through 7.2 recorded. Okay. All right, you guys. So that's kind of that. 7.1 is kind of like the intro. 7.2 is like the, I don't want to say the application, but it kind of gets you going where you can see how you could use arc cosine and arc sines now to maybe cancel things out or do some work. Okay. So I'm going to end the video on that. Hopefully that gives you guys enough time to get, or gives you enough information. Please, meet with me if you have any questions. All right. Thanks, you guys. Thanks for watching, and I'll see you in the next video.